So this part of day one is talking about how to simplify radicals. So how do we make that big number inside a little bit more manageable so that we can estimate it? That is the reason why we do this, is so that estimation becomes a little easier. So last screen was talking about some vocabulary, and now we're going to talk some vocabulary about what the parts of a radical. So the first part of a radical that you need to know is that little tiny number. That little tiny number, that is called the index. And that's what tells you what root you have. If you have a square root, we'll talk about what that looks like. If we have a cube root, we just finished our unit on that. You could have a fourth root, fifth root, sixth root, 10th root, any of those things. That piece that is underneath the radical, we call that the radicand, and we're going to use that term a lot, okay? So that piece that is underneath, that is called the radicand, and then that little slash, that is called the radical. We try not to call it a square root because it's not always a square root, sometimes it's a cube root, so we're always going to try to call it a radical. Really important thing to note, if there is not a number in the index, you're going to assume it is a 2. We use square roots a lot, so we just kind of shortcut it and just not write that 2. But so if you just have the radical with no index out in front, that index is a 2, and that becomes important when we start making our grouping and our trees. So let's talk about some trees, because we're going to do trees for every problem that we have. So write prime factorization of the following. Prime factorization. Prime numbers are those numbers that can only be divisible by 1 and itself. So some examples of prime numbers, obviously 1, 3, 5, 7, 11, 13, 17, and then so on. Only a number that can be multiplied by 1 and itself. So when we're writing the prime factorization of these, I usually will always start with 2 and 3. So will 2 go into 42? Yes. So that is 2 and 21. And then what will go into 21? 2 won't go into 21, but 3 will. So 3 and 7. And each one of those at the bottom of the tree, those are all my prime numbers. If I were to multiply 2 times 3 times 7, I would get 21 back. So if I multiply all of my prime numbers back together, I'll get that big number that's back up top. 2 is prime, 3 is prime, 7 is prime. 120, again, 2 will go into 120. It's even, so if it's even, it's divisible by 2. So that is 2 and 60. 60 is 2 and 30. And then 30, 2 can go into 30, but so can 3. It doesn't matter which one you do. You'll end up with the same numbers at the bottom. I usually just deal with 2's. So that's 2 and 15, and then 15. 2 won't go into 15, but 3 will. So that is 3 and 5. So all of that at the bottom, all of that is my prime. Those are my prime numbers. Now there are other things that will go into 120. So maybe let's say you wanted to start at 60 and you went 6 and 10. That's fine, but then your trees get kind of like all wonky and like, where's the end, where's the not the end? If you go about it this way and just go 2, 2, 2, and then so on, your diagonal is always going to be your prime number. So it just is a little easier to visualize, like, where did my tree end, and so I don't have like one branch ending here, one branch ending here, and then like another branch ending way down here. So it just cleans it up and makes it easier to find those bottom numbers, especially with what we're going to do with it next. All right, and then finally 225. 225, 2 won't go into it, 3 will. The other thing that will go into 225 is 5. It ends in a 5. So if I see 5s, I usually go with 5s. But I'm going to go with my rule of starting with 2 or 3. So I'm going to go with 3. 225 divided by 3 is 75. So 75, again, can be divisible by 5 because it ends in a 5. But I'm going to go with the 3. So that's 3 and 25. 25 is 5 and 5. So each one of those are my prime numbers. 3, 3, 5, and 5, they're all prime. 3 times 3 times 5 times 5 will give me back to 225. So now let's use this knowledge with simplifying radicals. So step 1, you're going to write the prime factorization of the radicand. Remember, radicand is that piece that's underneath. So we're going to prime factorize it, which means we make our trees. Okay, so we're going to prime factorization the radicand. Step 2, you're going to expand the variables if applicable. If you have variables, if it is x to the 3rd, you're going to write x, x, x. If it is x to the 7th, you're going to write, it's annoying, yes, 7 x's. Then you're going to circle groups based on your index. So that's why I said if your index is invisible, your index is 2. But if your index is 3, then you're going to circle triplets. If your index is 4, you're going to circle quadruplets. Okay? They have to all be the same, and you have to have that many in the group. Step 4, you're going to pull out groups for each duplicate. So what do I mean by that? This will make more sense when we get there. But if you have a group of 2, you're going to pull out a group of 2. If you have a group of x's, you're going to pull out that group of x's. If you have a group of 2 and x, you're going to pull out both groups, both 2 and x. You're going to multiply those together. We'll get that in that step 5. But then everything else stays underneath, stays in the radicand. Step 5, you're going to multiply everything outside. So if there already was something there, you're going to multiply your new groups with that group. And you're going to multiply everything outside together, and then you're going to multiply everything underneath together. I call the underneath the leftovers. So you're going to multiply everything left over and put that back underneath. So first example, square root of 50. 50 is even, so I'm going to go with 2, so that is 2 and 25. And 25 is 5 and 5. I'm going to circle my groups based on my index. Now my index is invisible. So an invisible index means that my index is 2. So I'm going to circle my doubles. I do have a double. My 5 is a double. So my groups go on the outside. My leftovers go underneath. So the one thing I had left over was the 2. So I'll explain where everything came from with some arrows. So the groups went one time on the outside. Just write them once, even though there's 2 of them, but they're now in one group. So my groups go outside, my leftovers, which is the 2, goes underneath. And that is that one simplified. Easier to estimate what that number is. The square root of 2 is 1 and some change, so 1 and some change times 5, that's 5 and some change. Square root of 50, you know, I don't know what number times itself could like kind of get close to 50. I mean, if I use my brain, I could, but it's easier for me to use my less of a brain on this one. All right, so now I have the 4th root of 64. So again, 64 is even, so I'm going to start with 2. So that is 2 and 32. Use your calculator if you're unsure. Just do 64 divided by 2. It's 2 and 32. 32 is even, so it's divisible by 2, and that's 2 and 16 is divisible by 2, and that is 2 and 8. Now at this point, again, 16 is divisible by 4, so you could do 4 and 4, but your trees get kind of a little off center. So if you do it this way, the edge of your trees are always going to be your prime numbers. You don't have like one tree ending here and then one tree ending here, and it just gets kind of wonky. So 8 is 2 and 4, and finally 4 is 2 and 2. So those are all of my prime numbers, lots of 2's. Lots of 2's. Now my index is 4, so I am circling my quadruplets. I am circling 4 of the same number if I have it. I do have a group of 4. Doesn't matter where you start your group. I usually start my group at the top corner, but you could start your group at the bottom corner and circle 4 2's. That's the goal. You're circling 4 2's. So that group goes on the outside. I have the 4th root of what's left over. What's left over is 2 and 2. I need to multiply my leftovers. So 2 times 2 is 4. So 4 is what goes underneath the radical and becomes my radicand. So the 2 times 2, again, just showing you that the 2 and the 2, you multiply your leftovers together. You would multiply if there are multiple things that go outside. You're going to multiply those together. I just have the 1 this time. But because I had 2 of the same thing, those got multiplied together and did go underneath. All right, let's talk about this one. What's different about this one is that I do have a number already on the outside. We'll talk about what that does to my final answer. To start with, it does nothing. This is also the first time we have a letter. But to start this one, it does nothing to change how I start. So I start with 20. It's even, so that's 2 and 10. 10 is 2 and 5. So also the first time we've got letters, so let's expand out those letters. 3x's. My index is invisible, so I'm circling my double. So I have a double 2. I also have a double x. All right, so that's just showing that my index was 0. Now, I'm going to put my groups together. So I have a group of 2 and I have a group of x. So normally I would put 2x on the outside, but I already have something on the outside. So that gets multiplied together. So the 2 and the x get multiplied by the 2 that was already there. So 2 times 2x is going to give me 4x. So that's where everything came from the outside. The 2 times the 2x became 4x. And then I have the square root of my leftovers. I have a leftover 5 and I have a leftover x. And so that's what goes underneath. A way I had a student remember this a while ago is that your leftovers go back in the fridge. So leftovers go back underneath. May help you, may not. Last example before we have the ones where you can just practice on your own. So I have 81. So 81 is not even. So it's not going to be able to divisible by 2. So I would try 3. 81 divided by 3 is 3 and 27. 27, not even, so I'm going to go with 3. That's 3 and 9, and 9 is 3 and 3. Those are all prime. 3, 3, 3, 3. Those are all prime. Now, x to the 5th, it's annoying, yes, but write out 5 x's. Y to the 3rd, write out 3 y's. All right, and so since my index is 3, I'm going to circle my triplets. So I do have a group of 3 3's. I have a group of 3 x's, and I have a group of 3 y's. So all of those groups are going to get multiplied together. 3 times x times y is just going to give me 3xy. Those are going to go to the outside of my radical. And then I'm a little, I guess, picky about this. I like to put, if I have an index that's not a square root, I like to put it inside parentheses because then I know that it's the index and it's not an exponent that's happening to one of the letters that came out. So it's not necessary, it just makes it easier for us teachers to understand that you know that it is a cube root and not y cubed, because otherwise they just get really jumbled. So I have the cube root of my leftovers. I have a 3 left over and I have 2 x's left over. X times x is x squared. So that is what gets left over. Leftovers go back in the fridge. So again, these are my groups. My 3, my x, and my y came outside, and my 3 and my 2 x's got left over inside. And that is simplifying radicals. Very easy. There are extra examples. We're going to go over those in class, but I encourage you, if you are at home working through these, work through them and then check our notes and ask questions if you have any.